Today we're going to continue looking at factoring with the lead coefficient of 1, talking about factoring perfect square trinomials, as well as continuing with the differences of two squares. So notice that in our directions, they're asking for us to factor completely. Remember, the first thing you always should be looking for when you're asked to factor completely is to look for a GCF. Notice that in the first part, 4x squared minus 81. So the 4 is definitely a number we can break down. Besides 1 times 4, notice that 4 is 2 times 2. If I look at the 81 and I think about how do I multiply to 81, notice that this is 9 times 9. Okay, well, technically I can break up the 9 into 3s. I'm not going to have anything in common between a 4 and an 81. So there is not going to be a GCF as far as numbers are concerned. Because the 81 doesn't have any variables, it doesn't have a GCF of numbers or letters, so no GCF. But notice that I wanted to break down the 4 as 2 times 2 and the 81 as 9 times 9 because, once again, those numbers are something called perfect square numbers. If you're looking at your multiplication chart, you will see these types of numbers all on the diagonal. And that's because the same number multiplied to get you the particular number. 4, like we said, is 2 times 2. 81 is 9 times 9. So since those numbers don't have anything in common, we get to take those numbers and go straight into our final answer, which will be two things multiplied together. Because that x squared has the 4 in front and 4 is 2 times 2, I'm not going to start off my parentheses with just x's today. Because 4 is 2 times 2, I'm going to have a 2x and a 2x. So the numbers that are alongside of the x squared need to go with the x's when you put them in the parentheses. Notice that because we are dealing with a negative 81, because of that subtraction sign, technically one of those 9s is negative and one of those is positive, because a negative times a positive is a negative. So that means the rest of my parenthesis is going to end with a negative 9 as well as a positive 9. And that would be my final answer. If I look at the second problem, we are dealing with 9x squared minus 16. So once again, if I start trying to look for that GCF, I can break down 9. Two numbers that multiply to 9, 3 and 3. Once again, notice that 9 is what we call a perfect square number. It's the same number multiplied twice to get that. If I look at the 16, notice how there's a couple different ways to break down the 16, but it is also one of those perfect square numbers. 4 times 4 is 16. Technically, if I try to break down that 4 even more, we'd get some 2s. But if I'm looking for a GCF, a 2 and a 3, or even a 4 and a 3, they don't have anything in common. Okay, because the 16 doesn't have any variables, there are no numbers or no letters that they both have in common. So once again, there is no GCF. So now, since there's no GCF, we can go ahead and we can write our final answer in those parentheses. Because the 9 is connected to x squared and 9 was 3 times 3, we want to put a 3 with each of the x's that we start off our parentheses with, because 3x times 3x is 9x squared. Don't forget that because the 16 is technically a negative, one of those 4's has to be positive while the other one has to be negative to multiply to that negative. So negative 4 and positive 4 are going to finish the rest of the parentheses, and that would be your final answer. So once again, those two problems are called difference of two squares because they are perfect square numbers. Now, if we take a look at these next problems, it says to factor the polynomials, but it also says take out the GCF first. I know I've been stressing this in previous lessons, but it's always important to make your very first step looking for a greatest common factor. Notice that if my first problem here is 3x squared minus 15x minus 42. Notice that 3 is one of those prime numbers. There's nothing that I can do to break that up any further. Because that's in front of the x squared, that is going to be my cue to look to see if I can break down these next two numbers to have a 3, because then that's going to be a number that they have in common. If I look at the 15, well, 3 times 5 gives you 15. So notice that the 3 is in both the 3 and the 15. If I want to come up with a number that I multiply 3 by to get 42, that's going to be 14. Okay, 3 times 14 is 42. So then notice that because there is a 3 in all of those terms, I am going to have a GCF of 3. If I start looking to see if they all have letters, I notice that the 42 doesn't. So that means that my GCF is only going to be that number. So remember, if I take out that GCF, my goal now is to put whatever's left over back in parentheses. So looking at my original problem, 3x squared, I took out the 3. So notice that the first term, I'm left with an x squared. I'm going to bring down that subtraction sign. 15 you can ignore because we broke that down into 3 times 5. But notice that the 3 we moved to the outside. So that means that there is a 5, and in the middle term, notice there's also an x. So 5x is going to be in the middle. I'm going to bring down that next subtraction sign. We get to ignore the 42 as well as that GCF of 3 because it was 3 times 14. My last term is going to be the number 14. And then once I have that, what I have in parentheses, we're back to the idea of having technically a 1 in front of the x squared. So we're asking ourselves what multiplies to the last number but adds to the number in the middle. So I want to know what multiplies to negative 14 but adds to negative 5. To multiply to a negative means that I want one negative and one positive. So if we try negative 7 times positive 2, that gives me negative 14. If I add those two numbers, it'll get me the negative 5 that I'm looking for. So then here's how I'm going to fill out my final answer. That original GCF of 3 needs to stay a part of my final answer. It gets brought down. Then in parentheses, I am going to go back to what we did as far as that table is concerned. Because the number inside the parentheses starts off as a 1x squared, I get to just make these 1x's to begin my parentheses. But notice that the numbers that I have in my chart that multiplied to negative 14 but added to negative 5, that is going to finish out each of these parentheses. So one of the parentheses has a negative 7, the other one a positive 2. With the GCF out in front, this is my final answer. So if we take a look at the next problem, 2x squared plus 30x plus 88. We got to look for GCF first. So looking at that first term, 2x squared. 2, once again, is one of those prime numbers. There's no other way besides 1 times 2 to get you 2. So that's my thought process now. Can I multiply 2 times something to get 30? Can I multiply 2 times something to get 88? Because if I can, that's my GCF. Well, notice that 2 times 15 is going to get you 30. Notice that 2 times 44 is going to multiply to get you 88. So each one of those terms has a 2 in common. That's a part of my GCF. If I look at all the letters, I want a letter in every single term. But the 88 is just a number, so that means my only thing that's going to go out in front of parentheses is the number 2. So then I want to write 3 things left over inside parentheses. So ignoring that GCF of 2, notice that I'm left with an x squared. I'm going to bring down that addition sign. We can ignore the 30 because we broke it up into 2 times 15, but we also get to ignore the 2 because that was the GCF. Notice that what we have in the middle then is the number 15, and don't lose the fact that the middle term also had that variable of x. Then I want that addition sign. Notice that I can ignore the 88 because I broke that down into 2 times 44, and I get to ignore the 2 because that was my GCF, which means the last thing left over is the number 44. So now, because I technically have a 1 in front of that x squared in parentheses, we are asking ourselves what multiplies to the last number but adds to the number in the middle. So I'm going to make a chart to find numbers that multiply to 44. So 11 times 4 multiplies to 44. If I add those two numbers, it will give me the 15 that I'm looking for. Don't forget, originally we had this GCF of 2. So I am going to bring that down, and I need to have a 2 in my beginning of my final answer. Then in parentheses, we have to put whatever's left over. So notice that because x squared just had that 1 in front, by taking out that GCF, we get to start each of our parentheses with a 1x. What we have then in the chart that multiplied to 44 but added to 15 is going to fill in the rest of my answer. So a positive 11 and a positive 4. With that GCF out in front, this is my final answer. If we take a look at the next problem, 5x to the third minus 45x. If I start by trying to break down the 5, I'm not going to be able to. So that 5 could potentially be a part of my GCF. If I look at 45, that is 5 times 9. So I'm able to find a number that they both have in common. That is going to be a part of the GCF. But notice that in the first term, it's x to the third power. In the second term, there is an x. They both have variables. So I look at the exponents to help me determine what do they have in common. To figure out what they have in common, it's actually going to be the smaller of the two exponents. So between a 3 and a 1, there's going to be one x in common because that 1 was smaller than the exponent of 3. So 5x is that GCF. So then in parentheses, I want to put whatever's left over. So ignoring the 5 from the first term, and if I take away 1x, I'm left with x squared. I'm going to bring down that subtraction sign, ignore the 45 because we broke that into 5 times 9, ignore the 5 because we moved that to the outside. We're going to bring down a 9. We get to ignore the x as well because we moved that outside. So here, 5x times x squared minus 9 starts off our factoring. But if you notice, what I have in parentheses is what we call a difference of two squares. Because there is no middle term of x, we can think of this as x squared plus 0x minus 9. And because there's a 1 in front of the x squared, we're asking ourselves what multiplies to the last number, but technically adds to this 0 in the middle. So if I'm thinking about my chart, what multiplies to a negative 9? Well, one positive and one negative. But they need to be the same number in order for us to have it add to 0. So I want to use these two numbers when I'm writing a part of my final answer. Don't lose the fact that 5x was that original GCF. So I move that down, and it's going to be out in front of my two parentheses. So because it's a 1x squared in that trinomial that we have in parentheses, I start each with a 1x. The negative 3 and the positive 3 fill in the rest of the parentheses, and this would be my answer. Okay, finally, if we look at this last one, we start with the 4x to the third. Notice that 4 you can technically break down into 2 and 2, but let's actually look at the number 4 for a second. Because that is the smallest number, let's see if we can get a 4 out of 20 and a 4 out of 24. And notice that 4 times 5 is 20 and 4 times 6 is 24. So even though 4 is not one of those prime numbers, it is the biggest number that they're going to have in common. So that's a part of my GCF. if I look at all of the variables, I see that I do have x's in every single one of those terms. X to the third, x squared, and then don't forget that last one is x to the first power. So just like the last problem, when I'm looking at all of these x's, I have to choose the smallest exponent because that's what they all have in common. So between a 3, a 2, and a 1 is the smallest, so there's just one x that they all have in common. So 4x is the GCF. In parentheses, then I have to put whatever's left over. So if I take out the if I take out the 4, I get to now not have that in parentheses. X to the third, I get to take out 1x, so that leaves me with x squared. Bring down that addition sign. I can ignore the 20 because they broke it up into 4 times 5. I can ignore the 4 because that got taken out as the GCF. That leaves me with a 5. Notice that x squared is what I started with, but I took out an x, and so I'm left with a 1x along with the 5. Bring down that subtraction sign. We can ignore the 24. That's 4 times 6. We get to ignore the 4 because that was the GCF. Notice that I'm left with then the number 6. Because it was x with that 24, but we took an x out, we get to cross that off as well. Here is my trinomial, x squared plus 5x minus 6. So when that's the case, because there's a 1 in front of the x squared, we are asking ourselves what multiplies to the last number but adds to the number in the middle. So I'm looking for numbers that multiply to negative 6. Because it needs to multiply to a negative, I need one of each sign. Okay, if I try negative 3 and positive 2, that multiplies to negative 6. Notice that when I try to add those numbers, though, it gives me negative 1. Even if I flip those two signs around, I'm still going to end up with the number 1, which is not the number that I have in the middle. I want a 5. So what's another way to multiply to 6 besides 3 and 2? Well, 6 and 1. I'm going to make the 1 negative so I can have a positive times a negative. If I add those together, 6 plus negative 1, that is going to get me to that positive 5 that I'm looking for. So those are the two numbers that I'm going to need in my parentheses. But once again, my original GCF of 4x needs to also be a part of my final answer. So we'll have 4x, and then in parentheses, we'll start each of those parentheses with the 1x because we had 1x in our parentheses after I took out the GCF. I want a positive 6 and a negative 1 to finish it out. And that would be my factored answer.